All right, we have the new Generac air-cooled controller out on the bench tonight, and we got it powered up. A little 12 volt or a 20 volt power supply using 12 volts. Nice power supply. We can tell the draw. So just running right now with the ECM. We also got the ECM and the controller powered up in I think I got it in manual standby mode here. We got 2.7 watts. I got the CAN bus connected, and I got some scopes connected to the CAN high signal or CAN low signal. CAN low. And I got it inverted over here so I can decode it. Either way, the new controller platform on this, they do not have a screen. Generac has decided to forego the display, and they want you to go to use their app to look at any operational data. Don't know if that's a good idea. A lot of technicians are not receiving that change too well. As techs, some techs do not like change. I'm not as concerned as that. I do see some problems, but I'm not going to focus on the problems. I kind of want to get familiar with the engine, and more importantly, if there is no screen, I want to be able to read ECM data without having to go onto an app. So what I'm hoping to do is decode the CAN bus data. They're using a J1939 protocol for the CAN bus, and 8-scope has a built-in J1939 decoder in it. Now, I got some CRC errors, and depending when I fire this up, I do get valid packets here. So I'm able to decode the packets. The problem is I don't have this fully online yet. Once I do, my hopes are to hook up some sensors and decode sensor data and be able to make a library of all the operational data so I can monitor this unit with my own software that I'm hoping to make with LabVIEW or whatever, and a J1939 adapter. There's plenty of them out there. You can even build one with an Arduino. But anyways, the first step is to get hooked up and get a signal, which I do have a signal. So now I got to start hooking up some sensors and creating different conditions. Let's say I get a sensor hooked into oil pressure, I get a valid run signal, and then I sweep the oil pressure input. Then I can find the packet in there that's changing, and I can, now I'll know what packet, what CAN packet, an ID refers to the oil pressure, kind of to oversimplify how you go about decoding CAN bus data. So anyways, and it's also getting me more familiar with the system. Generally in the trade, the air-cooled generators were thought of as the beginner units. That said, I've seen some big, heavy, big iron generator techs come and get their ass kicked on an air-cooled. An air-cooled generator has to make all their power at 3,600 RPMs in order to produce the 60 hertz output. And they got to do that with 2 cylinders with a fuel supply that can fluctuate. It can be LP, it can be propane, it can have turbulence. It can be LP or it can be natural gas. It can have turbulence. And these things got to respond to load changes, and keep the exact speed depending on load and changes in fuel pressure. It's a lot to ask for a little air-cooled generator, and so they got to be running perfect, in other words. And just because they're a little small generator does not make them simple to work on. They can give you a headache. So anyways, now that they're throwing an ECM into the mix, some technicians that are not too familiar with sensor-based diagnostics, oxygen sensor signals, 5-volt reference, CAN bus data, they may have a hard time with these. But Generac has done a really good job with the book, the book for this. And they really they must have took their time and known that what they're asking, you know, with this big change for technicians to basically get accustomed to. And they really, I can't get over how well they made this book. I mean, they get into the crankshaft reluctor. The crankshaft position sensor is the reluctor is a 24-1. They go into the theory of how that operates. So I think it's a good opportunity for technicians to get comfortable with ECM diagnostics, and then they'll be able to apply it to the liquid-cooled units, because this system now basically has most of the sensors that would be in a normal PSI liquid-cooled engine or an IMCO liquid-cooled engine. You know, and then it's another good opportunity for them to get into using a scope or a graphing multimeter to start looking at, you know, O2 trends. You'll be able to see if the system has fuel control. You know, instead of looking at mag pickup, you know, some generators, the newer ones, aren't really using a mag pickup on the air cooled. They're using either ignition pulse or output frequency. So now they can get into with a little scope and start looking at, see if the engine has good, you know, a valid crankshaft position signal. They can see the trend of the O2 to see if we got a good fuel control. It's just a good way to get introduced to ECM-based diagnostics, I guess, is put as simple as that, without being too intimidated. It's a small little air-cooled engine, but it's got all the sensors. It's got a TT map. Usually we have T map, but now they're adding a second T to the T map, and throttle position switch, temperature, and manifold absolute pressure. We got a mixer, control valve, so we got all the sensors in this. So again, instead of complaining about the system, I think it's a good introduction to ECMs and closed loop and open loop and all that good old stuff we like about ECM, electronically managed engines. So I thought I'd show that kind of a different direction Generac is going. Be interesting to see if Kohler goes through with an ECM engine. Magnetos, so we're not going to have to do magnetos. Magnetos is a big job, not a big job, but you just can't change a magneto. You gotta get into where they are. So that's one good thing. So there's some positives I like about the platform. I know in the beginning, like any platform that gets rolled out, there'll be headaches. I've heard of the headaches, haven't experienced the headaches, but once it gets cooking, I think guys are going to learn. It's going to help people learn, and maybe once all the kinks are out, maybe these things will respond better, and be able to adjust to different fuel sources and pressure due to the way the mixer and with the mixer control valve, maybe they'll be able to respond to a variance in fuel pressure more than the regular units go. That just basically, you got a throttle valve right interfacing right with the regulator diaphragm, where we got mixer control valves and stuff now. I kind of think it's neat. Little bored with old air-cooled engines, and like at our company, we work on everything from 8 kW generators up to a megawatt and over, and you know, so every technician will be working on this stuff, and just to ignore it and not learn it, I'm a fan of learning it in a comfortable room on the bench, and then once we see it in the wild, we don't look like a deer in the headlights. We get to kind of look like we know what we're doing in front of the customer, instead of flipping through the book, wondering what the hell we're doing. So there we go. Got the engine control, CAN bus, ECM, and forget mixed sig. H-Scope's winning the prize today on CAN bus data acquisition. That's it.